Okay, we're going to talk about today the other asymptotes in rational functions. We've already talked about horizontal and vertical asymptotes, and the other asymptotes that you can have is what's called a slant or oblique asymptote and a parabolic asymptote, and these are all dependent upon the degrees of the numerator and the denominator. When we talked about horizontal asymptotes, we talked about how the degrees were either the same or the degree of the denominator is greater. But with slant and parabolic asymptotes, we look at the fact that the degree of the numerator is more. So if you look at our problem here, number 5, talking about slant asymptote, if we look at the x squared over x, the leading or the largest terms in each the numerator and denominator, we know that these would reduce to x, which is a line which is on a slant. And so what we're going to do is use either synthetic or long division to find the actual asymptote here. So we will take and use synthetic division. So we'll choose the number 5 here and put it into 1, -1, and -2, and do our synthetic division. So we bring down the 1. 5 times 1 is 5. -1 plus 5 is 4. And 5 times 4 is 20. So we get 18. Now when we're doing slant or parabolic asymptotes, we ignore the remainder because that's not going to affect it. And our asymptote in this case is going to be y equals x plus 4. Now if we take and graph this function, so if we look at take our Smart View, our calculator, and actually graph this, and we go to our y equals, and let's see, we're going to put in our y equals here. Let's go ahead and clear this and start over. And so we go alpha y equals, and we'll use our fraction. In the numerator we have x squared minus x minus 2. And in the denominator then we're going to have x minus 5. And our answer in this case is x plus 4, so we'll put x plus 4 was our vertical asymptote, or our slant asymptote. And if I graph these then, and I have a pretty good sized window here so we can see all of it. I think I'm going to have to change this. Yes, I am. Let's go zoom 6 so we can look at the window to start with. And if you look at the window here, there's a part missing here because this graph should also go up. So we're going to have to increase our window. So we'll go from, say, -20 to 20 for our x, and we'll try that with the y too to see what happens. And graph it, and we get there. Oh, then we can see it a little bit there, but we're going to need to go a little bit higher, looks like. So we'll go change our y max to 30, and our y max, we'll take that one up to 40. Let's see what we can see here, and graph it. And we can see that the line here, x plus 4, follows along the line of the graph here, and so that you can see that how that asymptote would go in there. Alright, and so there's our slant asymptote. Now the other type that we were talking about is a parabolic asymptote, and for a parabolic asymptote we're going to do the same thing. We're going to use synthetic or long division to get that one. But now when we look at this, for the parabolic, you can see that we have x cubed is our largest term, and x is the largest term in the denominator. If we simplify that, we get x squared. So the reason it's called a parabolic is because it's going to be like a parabola. And so if we do synthetic, or we could do long division, so let's do synthetic, that's the easiest one when we can use it. And a 1. So we bring down our 1, multiply them, and we get 1. So we have 4 here. And 1 times 4 is 4. So we get 5, and 1 times 5 is 5. So our, once again, we're going to ignore the remainder, and our asymptote here would be y equals x squared plus 4x plus 5. And once again, if we graph both of these, then we will also have that same that this right here graph would be show that, and I can show you that real quick here. Let's take a picture of this. If we change, then if you look at this graph right here, then you can see that that's where it is, that it comes down through here and back up this way. So it's the end behavior as x gets really large either direction, and that would be slant and parabolic asymptotes.